In this video, we're going to work example problems from the opening section of the trigonometry textbook. This section was on angles. It was a review of angles. So really the concept of angles is more officially learned in geometry, but in trigonometry, we start by reviewing what exactly an angle is, and we just talked about different topics related to angles. And so now we're going to work an array of different example problems. Okay, let's fill in all of these blanks. 1 degree, written 1 degree, represents how much of a complete rotation? Well, okay, this is 1/360th. There's 360 degrees in a full rotation. If the measure of an angle is x degrees, its complement can be expressed as what minus x degrees? So a complement, the idea of a complement, or two angles that are complementary, is referring to two positive angles. Those angles have to be positive. And the idea is that those two angles, if they sum to 90 degrees, then those two angles are complements. So if the measure of one angle is x degrees, then its complement would be 90 degrees minus x degrees. Okay, if the measure of an angle is x degrees, its supplement is exact same concept as complement, except the angles add to 180 degrees. It's two positive angles. And so every positive angle is going to have only one complement or only one supplement. So if you have an angle whose measure is x degrees, its supplement is going to be 180 degrees minus x degrees. The measure of an angle that is its own complement is what? Well, that's going to be 45 degrees. 45 plus 45 is 90. The measure of an angle that is its own supplement is going to be 90 degrees. 90 plus 90 is 180. 1 minute, written like this, 1 minute is what? How much of a degree? Okay, we know that 1 minute is, they call it a minute because you think of degree like an hour, and so a minute is a 60th of a degree. A minute is a 60th of an hour. Since you're thinking about a degree as like an hour, then a minute is 1/60th of a degree. And then in the same way, a second is how much of a minute? It's a 60th of a minute. The only difference is if you're asking, well, okay, you think about a full rotation, you would think, okay, well then if a degree is like hours, then a full rotation would be 24 degrees, like 24 hours. It doesn't work that way. You go from minutes to degrees, then you go from you skip a full rotation of the Earth and you think about just a full rotation of the Earth about the sun. So you say that a full rotation is, but you don't say 365 degrees, like 365 days in a year. You just say 360 degrees. There's 60 seconds in 1 minute. We're talking about an angle measurement. So as far as angle measurement, there's 60 seconds in 1 minute, 60 minutes in 1 degree, where a degree is kind of like hours. But then the 24 hours in a day kind of idea, you skip that and you just say there's 360 degrees in a full rotation. You just jump to that idea of rotating about the sun. 12 degrees, 30 minutes, written in decimal degrees is, okay, so you've got 12 degrees, and then how many minutes are in 1 degree? Well, there's 60 minutes in a degree, so take 30 divided by 60. So that's 12.5 degrees. Okay, now 55.25 degrees, we're going the other direction. We're going to put this in minutes, in degrees and minutes like this. So we know we have 55 degrees. Okay, but now 0.25 of a degree. How many minutes is that? Well, okay, 60 minutes in 1 degree. So a quarter of 60. That's 15. So 55 degrees, 15 minutes. If n represents any integer, then an expression representing all angles coterminal with 45 degrees is what? all angles coterminal with 45 degrees. What does coterminal mean? That means that, so coterminal, co means like the same. So if you think about an angle in standard position, you've got the initial side is along the positive x-axis. Then the terminal side, the vertex is here. The terminal side is anywhere in the 3D, in the 2D plane. If they're coterminal, then they have the same terminal position. But it's not necessarily the same angle, because you could do more than one rotation, positive or negative. So what this means is that any angle that's going to be coterminal with 45 degrees is going to be some multiple of 360 degrees from 45 in the positive or negative direction. So you would do 360 times n, where n is any integer, positive or negative. So an angle that's 45 degrees plus 360 times n, where n is any integer, positive or negative, is, so if this was, if this is 45, right, that's about 45, and then you do 360 n, then that angle, 45 plus 360 n, is going to have this same terminal position. Find the measure of the complement and the supplement of an angle with the given measure. So this angle is going to have one complement and one supplement, because remember, complementary and supplementary angles, they're two positive angles. So what's the complement of 30? Well, what positive angle adds to 30 to produce 90? 60. What's the supplement of 30? Well, what angle adds to 30 to produce 180? Positive angle, 150. Okay. What is the complement of 45 degrees? Well, it's its own complement. 45 plus 45 is 90. What is the supplement of 45 degrees? What angle, when you add 45 to it, gives 180? 135 degrees. And the definition of complements and supplements, it specifies it's two positive angles, because they don't want to introduce, like, you could add minus 135 to 225 or something like that to get 90. And so are those two angles complements? No, those aren't complements. You're strictly talking about positive angles. Okay, what angle is the complement of 54? What angle, when you add it to 54, produces 90? So it's harder to just do this mentally. So if we're not going to do it mentally, how do we figure out what the complement is? Well, you say 90 minus 54, right? 36 degrees. 36 plus 54 is 90. That's the complement of 54. What about the supplement? Well, you do 180 minus 54. 126 degrees is the supplement of 54 degrees. And notice that the way they're saying this, it's like the supplement, the complement. It's the only one. You can't find another complement to 54 degrees other than 36 degrees. Okay, 1 degree. What is the complement of 1 degree? It's 89 degrees. What is the supplement of 1 degree? It's 179 degrees. Okay, what is the complement of 14 degrees, 20 minutes? This is an angle measure, and it's in units of degrees. You might say, well, it's not degrees, it's minutes. But remember, minutes is a fraction of a degree. It just represents a fraction of a degree. So what angle, when you add to this, produces exactly 90 degrees? Well, okay, what's 90 minus 14? So 90, 80, it's 76 degrees. But then we've got 20 minutes, so we're going to add to this 75 degrees and then a certain amount of minutes. So 75 plus 14 is what? 89 degrees. 75 plus 14 degrees, 20 minutes is 89 degrees, 20 minutes. Well, we need to get to 60 minutes to get to 90. So 75 degrees, 40 minutes. And if we wanted to, we could put this in just like decimal degree, like decimals of a degree. We just saw how to do that a few problems ago. Okay, what about the supplement? Well, same idea. 180 minus 14 is 166. So, okay, 166 plus 14 is 180. So, we need to do 165. So 165 degrees plus 14 is 169 degrees. Okay, 165 plus 14 degrees, 20 minutes is 169 degrees, 20 minutes. So we need to do 165 degrees, 40 minutes. Okay. What is the complement of this? So same idea. We do, so 90 minus 21 is going to be 69 degrees. And we did 21 because we're going to think about it like, what's 69 degrees plus 20 degrees, 10 minutes, 30 seconds? That's 89 degrees, 10 minutes, 30 seconds. So what's missing to get to 90? Like we can think about it, what's 1 degree minus 10 minutes, 30 seconds of a degree? Well, okay, we can think about it with the parallel between like seconds, minutes, and hours. How many minutes and seconds is 10 minutes, 30 seconds below 1 hour? Okay, well, it's 50, it'd be 49 minutes. So that would get 59 minutes, 30 seconds, 49 minutes, 30 seconds. So 69 degrees, 49 minutes, this would be seconds, 30 seconds. Okay. The supplement is going to be, so same idea, 180 minus 21 is 159 degrees. And then, so 159 plus 20 degrees, 10 minutes, 30 seconds is 169, 10 minutes, 30 seconds. And that's same idea, 49 minutes, 30 seconds. If you add this, if you add 159 degrees, 49 minutes, 30 seconds to 20 degrees, 10 minutes, 30 seconds, you're going to get exactly 180 degrees. All right, find the measure of each marked angle. So we want to get this angle and this angle. They don't give us the angle. They just give us like a formula for the angle. Okay, so how do we do this? Well, we know that these two angles are going to add to 180 degrees. We've got this straight line here. Or if we're going by the definitions that we've learned in this section, these two angles are supplementary. So they add to 180 degrees. So we do 7x, we can make a formula. 7x plus 11x is equal to 180. So 7x plus 11x is 18x. Divide both sides by 18. 180 divided by 18 is 10. Okay, so now we can see that this angle, 7 times 10, is 70 degrees. And then this angle is going to be 110 degrees. Okay, we can see that these two, they give this symbol here. That means these are 90 degree. This is a 90-degree angle between this side and this side. So that means these two angles are complementary. So 4x plus 2x is equal to 90. 4x plus 2x is 6x. Divide both sides by 6. X is equal to, so 90, 15. Okay, so 4 times 15 is 60. And that means this is going to be 30. Okay, so here, remember, everything we talked about in this section, we usually had like, lines that were going purely left to right or purely up and down. But all of these concepts, not only they apply to any orientation of a line, and not just in a plane, but even in 3D space. Right? You can have a line that's going through just completely randomly oriented. Well, this angle here, if you think about this like in a plane, that's 180 degrees. You can have a line in any orientation, in any plane. Well, that's 90, right? And so if we look here, we've got a straight line here. And so this angle is 180 degrees. That means that these two angles are supplementary. So, okay, minus 14x plus minus 4x. That's what supplementary means. You add the angles and you get 180. You add minus 14x to minus 4x, and we're going to get 180. Minus 14. So we've got minus 14x minus 4x is equal to 180. Minus 14 minus 4 is minus 18x. Divide both sides by minus 18. And you get x is equal to minus 10. So this angle is going to be 140 degrees. Minus 14 times minus 10 is positive 140. This angle is going to be minus 4 times minus 10 is 40 degrees. Find the measure of the smaller angle formed by the hands of a clock at the following times. So they want to know, what is this angle? So how can we figure this out? Well, what they're wanting us to do is that we know, like, okay, if we have a hand that's here, then relative to 12, it's gone 1/12 of a rotation, of a full rotation. Here, 2/12, 3/12, 4/12, 5/12. But with that, we know that a full rotation is 360 degrees. So we can use these reference points to figure out how far of a rotation we've gone. And so it looks like this hand here is like, I guess, halfway between 1 and 2. So that's not a 1/12 of a rotation. That's a 1/12 plus 1/24 of a rotation. So this here is 2/24 plus 1/12 plus 1/24 of a rotation. Okay, so 1/12 is 2/24 plus 1/24. That's 3/24. 8 times 3 is 24. So this is 1/8. We have rotated, when we go from here to here, we've rotated 1/8 of a full rotation. Well, a full rotation is 360 degrees. So 8 times 4 is 36. So this is going to be 40. So we can say that this is 40 degrees. And we're not thinking about positive or negative. We're just looking at, how big is this angle? Okay, well, this is going to be 90 degrees. Between the 12 and the 9, it's 90 degrees. So 90 plus 40 is 130 degrees. So 130 degrees. Okay, here we've got, it's directly on the 5 and the 12. So, okay, we're looking for this angle. So 1, 2, 3, 4, 5. 5/12 of the way of the full rotation, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've gone 5/12 of the full rotation around the circle, but one full rotation in terms of degrees is 360 degrees. So we just want to take this fraction of 360. Okay, 12 times 3 is 36, so this is going to be 30. Okay, 30 times 5 is 150. This angle here is 150. Okay, perform each calculation. What is 62 degrees, 18 minutes, plus 21 degrees, 41 minutes? Well, you can think about this just like if you were adding days and hours. Like if you had 5 days, 30 hours, plus 10 days, 21 hours. How would you do that? Well, you just start by adding the days together and then the hours together. That's the first thing you do. So 62 plus 21 is 83. Okay, then 18 plus 41 is 59. And then what you would do is you would look at like if you're doing like days to hours, you'd have a final number for the hours, and if that number was above 24, then you would like take a day out of that, right? If like you added up a certain amount of days and hours together, two separate days, hours combinations together, and you got your final answer was like, 18 days, 38 hours. Well, there's 24 hours in a day, right? So you want to take that 38 hours and take out a day and combine it with the days. Okay, but we don't need to actually do that here because we've got 59 minutes. We didn't get to 60 minutes. So we're still in a fraction of a degree here. So this is it. Right? It's like if you added 3 days, 5 hours, plus 8 days, 7 hours. Well, then you're going to get something amount of days and then like something below 24 hours. And so you're done. Okay, here it's just the same idea. But we just need to be a little careful because, okay, so we subtract, if we just think about subtracting 47 degrees from 71 degrees. So that's 24 degrees. So that's going to be minus 24 degrees. But if you think about it, it's actually going to be minus 23 degrees and then something minutes. You can't just say 47 minus 71 is minus 24, then 29 minus 18 is 11, so minus 24 degrees, 11 minutes. You can't do that. It's kind of like if you were subtracting 47 minutes, 11 seconds in time, minus 71 minutes, 18 seconds. You got to be careful, right? So, because, we subtract 47 minus 71 and we get minus 24, but we're actually subtracting 47 kind of like 47.5 minus 71.3. So we're not getting all the way to minus 24. We're gonna be a little bit larger than minus 24, so minus 23 point something. And if you notice, we're going to come up 11 minutes short of getting to minus 24 exactly, which means we're going to be at 49 minutes. We're 11 minutes short. So subtracting angles in like degrees, minutes, and seconds is a little bit trickier. It's not as straightforward as adding. And it's strictly from the standpoint of, you can imagine adding, something in minutes and seconds and time is going to be simpler than if you have to subtract like a certain amount of minutes and seconds from another amount of minutes and seconds. Okay, 180 degrees minus 119 degrees, 26 minutes. So if we do 180 minus 119, you get 6, so 61 degrees. But, well, actually, are we going to get to 61 degrees? So we would get to 61 degrees, and then we go 26 minutes further subtracting. So this is going to be 61 degrees minus 26 minutes. Well, okay, that's going to be, well, no, we'll have 60 degrees then. And then what's 60 minus 26? That's 36 minutes. Or no, 34 minutes. Okay, let's do this addition first. So 26 plus 18 is 44 degrees. 17 plus 20 is 37. 37 is less than 60, so this is it here. So now we want to subtract 14 degrees, 10 minutes. So 44 minus 14 is 30 degrees. Okay, now, but are we going to go below 30 degrees? Well, no, because this 44 degrees, 37 minutes we're going to stay above, like it's like we have 44.7 minus 14.2. That's going to be 30 point something. It's going to be 30 degrees, 27 minutes. Okay, convert each angle measure to decimal degrees. If applicable, round to the nearest thousandth of a degree. So we want to convert 35 degrees, 30 minutes to just like pure degrees. So this is going to be a decimal, right? Because the minutes and seconds represent fractions of a degree. So, okay, we've got 35 degrees. Now, what does 30 minutes mean? Well, 1 minute is a 60th of a degree. So we've got 30 divided by 60. Now we're in degrees. So this is 0.5. So we've got 35.5 degrees. Okay, minus 60 degrees, 12 minutes. This is minus 60 degrees plus 12 minutes. But, okay, I guess in the previous example, I think doing this plus here probably wasn't the best way to do it. And I say that because you don't want to do that here, because all this means is like, it would be like if I had, if I had the fraction 4.5. Okay, well, yeah, I could say that's like 4 plus 1/2, right? That's 4.5. That's true. But if I said minus 4.5, I'm not saying minus 4 plus 1/2, and so that's what? Minus 3.5. Well, no, of course not, right? This means minus 4.5. So really what we're doing is we want to say how much of what is this in degrees? So they have 12 minutes and there's 60 minutes in 1 degree. So now we're in degrees. So 12 divided by 2 is 6. 6 divided by 3 is 2. So this is 1/5. Yeah, 12 times 5 is 60, right? 12, 24, 36. Yeah. So this is a 1/5 of a degree. Okay, 1/5 is 2/10, so it's 0.2. So this is minus 60.2 degrees. That's this. Okay, so we've got 91 degrees, and we could do that plus idea here, and that'd be fine. But I want to get away from that. So, all right, minutes. How many degrees is that? 35 minutes, that's 35 divided by 60 degrees. Now the seconds, how would we do this if we were trying to say how many seconds are in an hour? How would we do that? Well, we would say, okay, we've got like 54 seconds times 1 minute is 60 seconds times 60 minutes is 1 hour. So you're dividing it by 3,600. Now, it's a little confusing because of when we talk about the, how minutes and seconds as far as angle measure is parallel to like the time measure, and it doesn't, days that could be confusing because it's like, well, there's 24 hours in a day. You don't think about 24 hours in a day. You just go straight to the comparison between a full rotation about the sun. It's kind of confusing, but the idea is there's 60 seconds, as far as angle measure, there's 60 seconds in a minute, and there's 60 minutes in a degree. So there's 3,600 seconds in a degree. So 54 seconds, now we've got degrees. And now here we could just add it, and we'll get the decimal. But if this was negative, then the idea would be like you would just like add these two and get a decimal and just stick that decimal on the end, But okay, so we've got 35 divided by 60 plus 54 divided by 3,600, 359 to the thousandth of a degree. We're going to round it, so 0.598. So 91.598 degrees. Okay, now we're gonna go the other direction. We want to convert the decimal to minutes and seconds, and if applicable, round to the nearest second. So, all right, we've got 39, and then 0.25 of a degree. That's a quarter of a degree. And so if a degree is 60 minutes, then that means we've got 15 minutes. So 39 degrees, 15 minutes. And then 0 seconds. There's no seconds. There's no fraction of a minute here. Okay. And so, you can think about, since a second is 1/3600th of a degree, then unless you've got at least the 1,000th decimal place for the degrees, you're not going to be dealing with seconds, right? So here we're going to have seconds. So we've got minus 18 degrees. And then now we want to see what is 0.515 degrees in minutes and seconds. And then we'll just tack that on to the end here. Okay. So what we can do is we can say that we've got 515 thousandths of a degree, right? And so let's go ahead and use seconds. So there's 3,600 seconds in 1 degree. And so these would cancel, and then we do this multiplication, we get seconds. We convert to seconds. So, oh no, why did I do, not seconds? No, that was completely incorrect. You don't put an S. That's time. It's seconds. Okay, so, all right. 10 divided by 2 is 5. 36 divided by 2 is 18. 515 divided by 5 is 103. And then 103 times 18, 1854. So we've got, that's what 515 equals to, 1,854 seconds. But we've got minutes wrapped up in here, right? We want to separate out the minutes. So what is 1854 divided by 60? 309 divided by 10. So 309 divided by 10. Let's separate this out. So So 309 divided by 10 is 30 and 9/10. So this is 30.9 minutes. Okay, so 0.9 minutes is how many seconds? So 9/10, and there's 60 seconds in a minute. That's 54 seconds. So this is 30 minutes, 54 seconds. So there we go. We just tack that on to the end here. It's minus 18 degrees, 30 minutes, 54 seconds. All right. So we've got 89 degrees, and then we've got this 9,004, then 10 thousandths. And then, so how many seconds is this? Okay, so, I mean, let's just go ahead and use a calculator. So 9. $81,036 divided by 25. And so is that, okay. Well, okay, it's this many seconds, but how many minutes is this? $54.024 minutes. Okay, so we've got 0.024 minutes is, so 24 thousandths of a minute is how many seconds? Well, there's 60 seconds in a minute. So 24 times 60 divided by 1,000. 36, 1.44. So, okay. This is 54 minutes, 1.44 seconds. That rounds down to 1. So this is, it's going to be approximately 89 degrees, 54 minutes, 1 second. Okay, find the angle of least positive measure, not equal to the given measure, that is coterminal with each angle. Okay, what does coterminal mean? Coterminal is, and if you think about an angle measured from like a standard position, you've got an XY plane, and the initial side is along the positive x-axis, and then the terminal side is anywhere in the plane. So let's use this angle as an example. If we put 32 degrees measured, a positive angle is measured counterclockwise. So if we go 32 degrees positive from this initial side, that's about like that. Okay. But you can, an angle can take on any number from negative infinity to infinity. A coterminal angle would be any angle that has the same terminal side as the 32 degrees. So what would that be? That would be like 32 plus 360, plus another 360, plus another 360, or 32 minus 360, minus another 360, minus another 360. Those are all coterminal. They have the same terminal side, right? This is the initial side. This is the terminal side. So what they're asking us here is find the angle of least positive measure, but not equal to the given measure, that is coterminal with each angle. So we can't, if we subtract 360, we'll get a coterminal angle, but it won't be positive. So the least positive measure that's not equal to this, this is like, so it can't be 32. It would just be 360 plus 32. That's 390 degrees. Or no, 392. Okay, least positive, that's coterminal with this. Well, we're just going to add 360 to this. 360 minus 40 is going to be 320 degrees. Okay, we're not going to add 360 here. We're going to subtract 360. That's the least positive angle. That's coterminal, right? If you think about it, what is 361 degrees? Well, if you rotate 360, then you just go 1, you're like right in here. Well, what's coterminal with that? 1 degree. Okay, here let's subtract 360, and if we're still above 360, we'll subtract 360 again. Because remember, coterminal, it's not like you just, it's not just if you're plus or minus 360 away, it's any multiple of plus or minus 360 away. It's going to be coterminal, right? If you take an angle and you add 720, that's coterminal. If you subtract 720, that's terminal. If you whatever 360 times 3 is, plus or minus that is coterminal. So, okay, 9 minus 0, 179, but we can't subtract 360 again, and we won't have a positive measure, so 179. Okay, so here we're just going to keep subtracting 360 until we get something between 0 and 360. So let's just use the calculator. 5280 minus 360 minus 360. I mean, there's probably a more efficient way to do this. Yeah, so okay. What is 360, let's say, times 10 is 3,600. What is 360 times 15? 5,400. So 360 times 14 is 5,040. So if we subtract 360 14 times from this, we get 5280 minus 5,040, 240. And so there you go. This is coterminal, and it's the least positive. Give two positive and two negative angles that are coterminal with the given quadrantal angle. So what does quadrantal mean? This is, every angle, if you're measuring it from standard position, it's going to lie in a quadrant, right? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4. But actually not every angle, because what if you have an angle of 90 degrees or 180 or 270? It's not in a quadrant, so these angles are quadrantal angles. All right, so what are two positive angles that are coterminal with this quadrantal angle? Okay, well, 90 plus 360, then plus 360 again. So 450 and 810. $450 and 810 degrees will all be the terminal side will be here. Okay, and minus 270 and minus 630. These also, so that remember, with a negative angle, we go from the initial side to the terminal side in the counterclockwise direction. These will also be here. These are all coterminal, all of these. Okay, well, this one's easy. So 360 and 720, and then minus 360 and minus 720. These are all coterminal. The initial side and the terminal side lie on top of one another. That's why the angle is 0 degrees. Write an expression that generates all angles coterminal with the given angle. Let n represent any integer. So we want to have an expression that represents every single possible coterminal angle that's coterminal with 30. Well, what we do is we say 30 plus 360 times n, where n is any integer, even 0. Technically, 30 is coterminal with 30. But think about this. If n can be absolutely any integer from negative infinity to infinity, then here we've represented every single possible angle that's coterminal with 30, right? Because anything coterminal with 30 is going to be some whole number multiple of 360 in the positive or negative direction. And this is the exact same thing, minus 90 plus 360n. You're just adding or subtracting some whole number multiple of 360 to the angle.